So the support vector machine algorithm is an algorithm used in machine learning to find some discriminatory logic between two distinct sets of data. Suppose you are supposed to classify a given text into abusive text and not abusive text. So you know there are certain features or parameters that you would use to determine if some text is abusive or not. So these are called features, and essentially obtaining these parameters out and tracking them is called feature engineering. So if I could map this on a Cartesian plane, abusive text may look something like this, while non-abusive text may look something like this. So what the SVM does is essentially draw a line in the middle, or draw a line like this, or draw a line like this, such that the line drawn should maximize this distance, which we call the margin, and minimize the number of incorrectly classified points on each side of the line. So I don't want an O here, I don't want an X here. Now, a lot of other applications of SVM essentially include banking, where you want to determine if a person would default on a loan or not. It's used in healthcare for early diagnosis of disease based on certain features like height, weight, temperature, race, and other such important parameters. It's been used in biology, in computational biology, to determine if a given nucleoreceptor binds to a given protein molecule or not, and other such classification tasks that have some distinct decision boundaries. So if I tap, or if I make use of more than two parameter features at a time, I can have an n-dimensional Cartesian plane with an optimal hyperplane instead of an optimal line. This forms the crux of what the SVM really is.